Let's do question 7. Here we have the function y equals 12 minus 3x squared plus 2e power 3x. Now we find the derivative of y. So we write dy by dx, which is the derivative of y. And this equals, we find the derivative of each of the terms on the right side. So the derivative of 12, which is a constant, is 0 minus we find the derivative of 3x squared, that is we put the constant 3, and then the derivative of x squared is 2x using the power rule of derivative, plus we put the 2 and then find the derivative of e power 3x. This is an exponential function, so the derivative of an exponential function is the exponential function multiplied with the derivative of the 3x, that is using the chain rule. The derivative of 3x is 3. So let's simplify this. So here we have dy by dx, but this equals negative 3 times 2 is negative 6x plus 2 times 3 is 6 e raised to the power of 3x. So therefore negative 6x plus 6 times of e power 3x is the derivative. In fact, we can also factor the 6 and write this in factor form. Let me put this first, that is e raised to the power of 3x minus x. And so this is the derivative of y. We now find the derivative of this function, that is y equals the square root of s cube plus 1. So here we are given y as a function of s. So therefore we have to find the derivative of y with respect to s. So first I'm going to write this in terms of power form. That is, the square root can be written as a power of 1 by 2. So I write s cube plus 1 raised to the power of 1 by 2. Now here we can consider that there are two functions. The outer function is basically the power function, and this is the inside function, which is s cube plus 1. So when we want to find the derivative of this y with respect to s, we first find the derivative of the outside function multiplied with the derivative of the inside part. So let's do that. So I write dy by ds, and this equals, we apply the power rule to find the derivative of this s cube plus 1 raised to the power of 1 by 2. So we put this 1 by 2 and put the inside part, that is s cube plus 1 raised to the power of 1 by 2 minus 1. This has to be multiplied with the derivative of s cube plus 1 according to the chain rule. So we write d by ds of s cube plus 1. Now let's simplify this in the next step. And so this equals 1 by 2. This is equivalent to s cube plus 1 raised to the power of half minus 1 is negative half, multiplied with the derivative of s cube plus 1. We find the derivative of s cube using the power rule, which gives 3s squared. And then the derivative of 1, which is a constant, is 0. So here we get 3s squared. Let's simplify this. So we can rewrite this as we have a 3 here and we have a 1 by 2. So 3 times 1 by 2 is 3 by 2. We then write this as a positive powers of 1 by 2. So therefore we can write this as 1 over s cube plus 1 raised to the power of positive half. And then this has to be multiplied with the s squared. Let's write down. So we can write this as 3s squared. We can multiply this 3 with s squared, and then this is over 2 times of, this can be written in a square root form. So it is 2 times of square root of s cube plus 1. And so this is the derivative of y with respect to s. Let's do question 9. So here we have the function f of x equals 6e power 5x plus e raised to the power of negative x squared. We find the derivative of f of x with respect to x, that is f prime of x, and this equals 6 times the derivative of e power 5x is e power 5x, and then apply the chain rule to find the derivative of 5x, which is 5. We then put the derivative of e power negative x squared is e raised to the power of negative x squared, and then once again apply the chain rule to find the derivative of negative x squared, which is negative 2x. Let's write them in simple form. 6 times 5 is 30. This is e raised to the power of 5x. We have negative 2x. We have positive here. So overall, it's going to be negative 2x times e raised to the power of negative x squared. And so this is the derivative of f of x. Let's do question 24. Here we have the function y equals square root of e power x plus 1. So I'm going to rewrite this as y equals e power x plus 1 raised to the power of 1 by 2. So let's find the derivative, that is dy by dx equals, first we apply the power rule to find the derivative of e power x plus 1 raised to the power of 1 by 2. That is, we put the power 1 by 2 and then put the inside part, which is e power x plus 1. This is raised to the power of 1 by 2 minus 1. This is according to the power rule of derivative. And then this has to be multiplied with the derivative of the inside part, which is e power x plus 1. And this is according to the chain rule of derivative. So let's simplify this. And this equals 1 by 2 times e power x plus 1. Half minus 1 is negative half, multiplied with the derivative of e power x plus 1 is, the derivative of e power x is e power x plus the derivative of 1 is 0. So we can just leave that. So let's put this in simple form. And so this equals, in the numerator we have e power x. I'm writing e power x. Here we can write this as a positive power of 1 by 2. And denominator we have 2. So I'm going to write e power x divided by 2 times of e power x plus 1 raised to the power of positive 1 by 2. Now this can be written in terms of radicals, that is e power x divided by 2 times of, we write this in terms of square root, because e power x plus 1 raised to the power of 1 by 2, we write this under the root of e power x plus 1. And so this is the derivative of y, that is dy by dx. And the derivative of this function p equals 1 plus natural logarithm of x raised to the power of zero point 0.5. First, I'm going to write this as p equals 1 plus natural logarithm of x. This zero point 0.5 can be written in terms of fraction as half. So I write this as 1 by 2. Now we find the derivative on both sides. That is dp by dx is the derivative of p with respect to x. And this equals, here we can apply the power rule. So I put the power first and then 1 plus natural logarithm of x. This one raised to the power of 1 by 2 minus 1. This has to be multiplied with the derivative of the inside part. That is d by dx of the inside part is 1 plus natural logarithm of x. So here we basically apply the power rule, and this is according to the chain rule. So let's simplify this. We have dp by dx, and this equals, we can write this as 1 by 2, 1 plus natural logarithm of x. 1 by 2 minus, this one is 1 by 2 minus 1 is negative half. So I write negative half multiplied with the derivative of 1 plus ln x is, this one is 0, and the derivative of a natural logarithm x is 1 by x. So I put 1 by x. Now let's put this in simple form. So we have dp by dx, and this equals, the denominator we have 2 and we have x here. So it will be 1 by 2x. And then this multiplied with this we write in terms of positive powers of half. So it will be 1 by 1 plus natural logarithm of x power 1 by 2. The next step, we can write this in terms of radical form. That is dp by dx, and this equals 1 by 2x times, we can write this in square root form. This is square root of 1 plus natural logarithm of x. And so this is the derivative of p with respect to x.